Um, so in an effort to give you guys a little heads up of what will be on the test, which is not this week but coming up, I'm gonna do an exit card tomorrow on Lopi calls to make sure that you have the process. Today's lesson is short, so hopefully we'll have time to go over the homework from Friday. And the way I'll be checking the homework is basically the exit card. So the first question, as x goes to infinity, if a over b goes to 0, what do you know about a or b? Kelly, what do you think?
B is like it's bottom heavy, so B has a greater polynomial.
So it doesn't have to be a polynomial. But if the fraction goes to 0, it's bottom heavy, which means that kind of infinity is bigger than the infinity that's on top. Camden, what do you think about number 2?
It's topic.
So what does that mean about the function a and b?
A is stronger.
So a is stronger, goes to infinity faster, it's a bigger number overall. Jamie, what do you think about the last one?
I said A over B equals 7.
Well, right, but what do you know about a and b?
That there's an asymptote.
There's a horizontal asymptote. And I'm saying equal power, and I don't necessarily mean exponent, meaning they have the same kind of going to infinity. So it could be an x squared over an x squared, like 7x squared plus 1 over 1x squared minus 3x. But it means that their strengths of approaching infinity are the same. So today is quantifying, like, how quickly do these things grow. We're going to try and formalize that n to the n feeble. So this function, e to the x, as it goes to infinity, goes to infinity. So does natural log of x. If you actually look at your book, they talk about these guys and how quickly they grow. By the time, if we got to the end of the board in terms of x, the red one, e to the x, would be at the moon, and the green one for natural log would still be on the board. So like it's a significant change in the growth. So the way we test to see which one is stronger or growing faster or has the most oomph to it, we're gonna do this thing. I might as well give it its name now. Spelling's not my thing. Limit comparison test. Some clever people read the assignment sheet, and tomorrow it says we're supposed to do an integration test and something else. I'm like, didn't we already have an integration test? And we are getting into chapter 9, and there are 9 different tests. Hang on, let me see. There's 8. T has been dropped, but my acronym of parting the C's doesn't work without the T. So I'll show you one example of T. You'll need it in some later calculus classes. But limit comparison test, which this is that C. This is full on chapter 9. What, Sean? What?
Something, I'm good.
All right. So doing this, comparing, if I plug in Infinity Loop, what do I get on both pieces? So I need to do the L'Hopital's thing. Testing the top and testing the bottom at infinity, pulling them out separately. Okay, they both go to infinity, so doing the derivative of the top over the derivative of the bottom. Good that I had that box there. Sophie, what's the derivative of the top?
E to the x,
Other Sophie, what's the derivative of the bottom?
1 over x.
And here, just do some arithmetic, this becomes x e to the x, which straight up just goes to infinity. So is it top heavy or bottom heavy? Top heavy. So, I mean, I think you knew this before, but this is how you can prove e to the x solidly goes to infinity so much faster than natural log of x. It's in a different order of magnitude bigger. Those of you who go to theoretical math, you will, you'll prove all kinds of fun things about the number system. But that's limit definition, limit comparison test. Okay?
Doesn't matter which, like if you're comparing to.
Doesn't matter which one you put on top. No. Because if we reverse them, we would have gotten that it goes to 0, which means it's bottom heavy. So, the kind of stuff that's on the homework is, hey, which one of these grows faster? So, what do we set up? How do we test? Data? Ooh, and this was weird. So, did it matter which one? No. And this, if I try to do L'Hopital's, the derivative of e to the x is e to the x. The derivative of 3 to the x is natural log of 3 times 3 to the x. Those things are never going to go away, so I need a different strategy that we haven't done since algebra 1, maybe? It's like, think about it. Is there some way I can change the look of this? Gabriel.
You can make the exponent negative and put it on the top.
Can't just make the x, I mean, e to the x times 3 to the negative x, how does that help me?
Or you can just subtract the exponents.
But that may need to be the same base. Okay, what does the brain trust over there think?
I would love to speak up now. Like, what's wrong with just saying he's 2.7 because 3 is greater?
Okay, that's the next step after we have the,
You pull the exponent out because it's the same thing. So it's just p over 3 to the x.
so e to the x over 3 to the x, that's e over 3 to the x. Algebra 1, what happens to this? Is it exponential growth or exponential decay, and how do you know, Ari?
Because he's less than 3. So it's a fraction. Definitely like go to 0.
Not because it's a fraction, but
So, like, it's
because
like a smaller fraction.
because this ratio is less than 1.
Yeah, less than 1.
So since the thing being raised to a power, algebra 1, this base is less than 1, the graph is going to go like that. So which one is stronger, e to the x or 3 to the x? 3 to the x, because it was on the bottom. I made the fraction go to 0. All right, there you go. This is a strategy that's not really explicitly taught anywhere, but keep it in mind. That if it's one base to the x and another base to the x, and pull the x out as the exponent. So I said this technique, what we're doing here is to formalize that. But these were both two examples of exponential. How do you know which one grows fastest? That's checking the base. Okay. Grady, what would I set up just to begin the test with this one?
The other side, 6x squared plus 9x all over 2x cubed.
As x goes to infinity.
Does it make it like harder for yourself to break apart this? Or does it make it easier?
Can we use a divide and conquer right here? Because Grady chose to put this one up top, we can break it apart. And that becomes 3 over x minus natural log of x minus 2x cubed. I think it was a helpful thing to do because I don't need to do L'Hopital's for the first piece. Sasha, where does this part go as x goes to infinity?
0.
And this one, not a polynomial over a polynomial. Sorry, you gotta pull the L'Hopital's out. You probably know the answer, but you need to do the steps. Okay. I'm on the list for something else though. Okay, great. Thanks. Silent Bob speaks. So L'Hopital's applies. And I told you guys Friday, if it's just a polynomial over a polynomial, you're allowed to say, hey, pre-cal happened. I know what that is gonna be. This, not a polynomial, so I needed to do this step. So for this other part, derivative of natural log of x. And that goes to 0. So what's the stronger thing? That one. Right. All right. Okay, can't do that. Question?
Yeah, I wasn't sure if it was like, because in that problem you had like the polynomial thingy that just went to 0 and then minus ln over 2x cubed or whatever it was. Is it minus the limit of that, or is it just like do you
Minus the
evaluate-
limit, that, it was still the limit. It was
So do you
a-
evaluate and then subtract and it just happened to be 0, or is it like do you evaluate it with it being negative?
Okay. If that's what's bothering you, maybe splitting it was a bad idea. You could leave it as all just one problem and just means doing your L'Hopital's is more of a pain. Not a big deal. But yeah, it's the limit of both pieces together. And I didn't show the work well because it's like, oh, this one just goes to 0 and I was lazy and didn't write it separately for the second one.
Yeah, I think it's this one and then minus the one over there. Yeah, that makes sense.
Grady, question?
So, no.
Arabella, what would we set up? And what goes out front?
Limit as x equals
And all of these are limited to x approaches infinity because they are end behaviors. We want to know what they're doing at the end of time. And when you see log, not ln, but log, oh, please, please, please change a base. Hannah, how do I do change a base with the denominator?
It'd be like ln x equals 1/2 over ln 10.
You said ln, sorry,
ln, I guess 1/2 ln x times, over 1 over ln 10.
okay. So I kind of wrote it as you were saying it. Natural log of x, they cancel. And one over 1/2, 1 divided by a half is actually multiplied by 2. And 1 divided by natural log of 10, 1 divided by 1 over natural log of 10. X's went away. I didn't even think about this. Crazy? Questions?
So does this mean that we do?
So they ride off into the sunset holding hands to root 10, to natural log of 10 part. Thank you. I don't know if there's this last example. Yeah, I just need to show you this Weedensky. Massimo, what's the inverse operation of squared? Square root. So there's a couple ways to reason this, and I haven't seen the AP exam be especially mean on this yet, but I feel it's coming. Because most people are like, okay, when we did polynomials in pre-cal, and it was 2x to the 7th minus 5x to the 3rd plus 4 over 3x to the 7th plus 8x to the 6th plus x. We're like, you know what? We just ignored these guys and we said they're equal powers, that's going to go to 2/3. So what you guys do often, you're like, well, in comparison to x to the 4th, that 2x isn't going to do anything. So x squared over the square root of x to the 4th, that's about even. I agree with you, and that is probably good enough, but I just want to show you an official way to do that. So Massimo said I can square and square root, okay? And the square root of one thing over the square root of another, I can bring the square root over both of them, yes? Yeah. And then I'm gonna do this, pull the limit inside. The limit of that polynomial is 1, the square root of 1. So I'm okay with the hand wavy ignoring this. But you need to actually prove it. This is a way to do it. Because I'm comfortable with that. Okay, and a note on tonight's homework from the textbook. I won't check it. It's one of those that do as much of it as you need to get the practice. So there's, I think it's 1 to 27 odd, and it's a lot of this one over that one, and doing a L'Hopital's check. I don't want to waste your time.
So do we just draw it the same way?
Did it come out to 0, infinity, or a number? So if you do the comparison of one function over the other, as x goes to infinity, it comes out to a number. Not 0, not infinity, same rate. So this one, 3/7, same rate. Questions on the homework? Just to point out, guys, 41, please be careful with the negative signs, because this came out to e to the negative 1, which is 1 over e. If you drop a negative, you got a really different number. 27. L'Hopital's doesn't apply right away. This isn't a fraction. Is there a way to apply, I don't know, maybe some log rules to smush stuff together to make
Number
this 27? Yeah.
I guess I would do ln of x over sin x.
So subtraction across logs is division within, and crazy business. And officially, I think on the first day of actual calculus in here, it's like, you guys just need to memorize this for now. I'll show you in like February or March how to evaluate this for real. So if you guys forgot this, as x goes to 0, that's 0. As x goes to 0 from the right, don't know why they said this, but they did. L'Hopital's applies. Derivative of the top, derivative of the bottom. Yeah, or, sorry, hold on. Or you could have just said, yo, I memorized that a long time ago. When as x goes to 0, x over sine x or sine x over x doesn't matter. That's going to go to 1. Why? Because I just did L'Hopital's. And natural log of 1 is 0. So yeah, what's your question, Sophie?
In the book, what they did is they had like they set like an f of x or like a y, whatever, equal to like the function, and then did ln and later did e.
Yeah.
Do you prefer e to that like ln and then?
Okay.
I think I'll forget it less.
Yeah. Okay. I've taught this a number of ways and tried to find the one that makes you not forget e the most, and I'm settling on this one. Different people respond differently, but if I keep the e each time with the limit, you guys are more likely to remember.
Are you allowed to take the e off in the beginning and like save it, or do you have to keep it
Um,
on?
You can, and if you forget it, it's at least -1. Because you'll get an answer of 0 instead of even 0, which is 1. Any other questions from these guys? Yeah, 25? Oh, yeah. There are pitfalls with some of these problems that if you don't stop and do some arithmetic, you're gonna spin your wheels forever. First thing, L'Hopital's doesn't apply because there's 3 different lumps. I need to do some kind of common denominator. Cosecant is 1 over sine. Cotangent is 1 over sine. Well, it looks like this guy's gotta become 1 over sine as well. Now I got a fraction. Preston, what do I do with that fraction?
So now use L'Hopital's evaluator. So it comes out to 0.
Cosine of 0 is 1, 1 minus 1, oh, okay, that's a 0. Sine of 0 is 0, so that goes to 0. So I really hate that they've introduced this rule. Okay, it's been like 10 years, but it still pisses me off. I didn't used to have to do this. Alex, what is the derivative of the top? Derivative of 1?
Yeah, 0.
Derivative of negative cosine? And the derivative of that product? We haven't done product rule in a while. First times the derivative of the second, so derivative of sine. Plus second times the derivative of first. Sasha, derivative of the denominator.
Cosine.
Well, now, if I plug in 0, the denominator is now 1. Plugging into the numerator, sine of 0 is 0. Cosine of 0, 1 times 1, and 0 times 0 over 1. Looks like 1.
So does that mean they're equal strengths?
Okay, yeah, if we were doing, so this is not doing the same thing as tonight's stuff. But if this was my function and that was my other function, I wanted to compare them, yeah, they're equal strengths.
In the beginning with the cosine x at the end, could we have just already plugged in 0 because they're added, and then just have +1 like hanging on? Because when I did that, I ended up getting 0, and then it was just 0 + 1.
Yeah, that works here. I'm just worried that sometimes you might need this bit or whatever to help with something combined later, but it should be fine.
Okay.
Like I cannot think of a place where that would be bad,
Okay.
but I'm not guaranteeing anything. Other questions from anything on the homework? Yeah. 29. How do we start?
Sorry, I just need to look at it. Oh, you have to make it like a fraction, so you could do like 1, or you could do like that thing. Yeah. And then, oh yeah, that is what I did. And then you could, sorry, I'm just looking at what I did. I moved like the limit inside, and then found that like both the top and the bottom of the
Okay, so now,
yeah, sorry.
now we move that down. So that's 1 over x, and 1 over x, and then this junk is in the numerator. Do I have a fraction? Yeah? So Nina, what do I have to do now?
You have to, so you to do a
Do L'Hopital's. And someone asked, do you need to know how to spell L'Hopital's? No. Because they couldn't decide themselves. There's different kinds. So what is that going to become? 0, is it 1? What is it?
0.
E to the 0 is 1 plus 0, so natural log of 1. E to what power is 1? I agree. 0. So L'Hopital's applies. Martin, how do I then apply it?
Don't you just do e to the 0?
I need to do the derivative of the top and the derivative. This was the test to see does L'Hopital's apply.
Oh, sorry. So 1 over L, or sorry, 1 over e to the x is x times e to the x.
Plus 1.
Oh yeah.
Because
And then over.
1 over stuff times derivative of stuff. Derivative of e to the x is e to the x. Derivative of x is 1. And then all of this over 1. Can I plug in 0 now? Okay. Plugging in 0, e to the 0 is 1 plus 1 over 1 plus 0. E squared. So many of them came out to be, oh, e to the 0 or e to the 1. You can get other numbers, including 4 or e to the 4 or natural log of 4. Other issues, yeah.
So if there's an exponent and you want to get rid of it, we can always do e to the ln. So
Often in the problems that are moving target to a moving target, you need to use natural log somehow. Again, when we did derivatives, something like that, we did natural log to both sides so that we could do implicit differentiation here, and over there we can do product rule. It's a way to make that variable to a variable problem go away. So you need to be familiar with the strategy. Were there any questions from 8.1? Did we do 8.1? This is a 2-day assignment, so any issues, other questions? Because you will have an exit card on these tomorrow. Okay. Here. This is what the homework looks like. Try some of them now if you find them trivial. Cool. Oh, wait. This is not the homework. 8.2 is the homework. So sorry. Stop. Where'd the cursor go? Oh, well, evidently we have none. Sorry. It's coming back. That's what the homework looks like. It's asking in the first batch to compare e to the x to these guys. In this one, they're asking you to compare x squared to each of these. I'm not asking you to do L'Hopital's 1,000 times, but reason through that.
It was too big, it was a bigger width. And then times the derivative, just do it's two side. Because you do this, it's two. I know it's changed. First you do derivative with the sine, which was in the square, and then times the derivative. Yeah.
I'm sorry.
Well, it's like, you drop the two, and then you place one side of the
It's just, it shows.
I'm very easy. I might ask her that. Yeah.
You can just say X squared is 3x plus 2.
Ari, you dropped out.
Yeah, I dropped it. I was for 5 years.
Yeah.
Like how like that one we're trying to say.
That's false, but we're in French right now. So.
Yeah, so
It's probably.
And it's spelled hospital without that.
yeah, you just yeah, so we agree.
Yes.
Why?
I don't know. I just wanted to make an assumption. Yeah, exactly. I wanted to, is that what's going on?
I'm pretty sure I shared it.
No, it's outside.
That was not his fault. I got it.
This little one in the MC. I did it wrong. It was just
Yeah, I think I'm right.
like EDX.
Oh, wait, you're great. No, I was thinking it's, I thought it was a, oh, you, oh, yeah. Oh, yeah. I know, they were really motivated when they really.
It was like actually crazy.
Yeah, so that's what I said. I'm not asking you to know what Michelle's 1,000 times, but to see the pattern. Okay. So, someone just asked about this one. I am not asking you to do L'Hopital's a lot, like 1,000 times. So Nina's like, can I just be like, no, do the derivative of the top, you get e to the x, always and forever. On the bottom, it's 1,000 x to the 999. Okay, 1,000 times 999 x to the 998. So you can see this is going to get lower and lower and lower each time, and e to the x still staying strong as e to the x. So that's what I said. Reason through it. Don't do L'Hopital's 1,000 times. One person did once just to be like, look, I did it. I'm like, and that's a day you'll never get back. Don't do that. Yeah, so like I said, the homework, grain of salt. If you get the gist, cool. Which one did you put on top? What's another one I can do with this before I get into the calculus?
subtract the exponents because the same reason.
Okay, subtract the exponents because they're the same base. So I'm gonna pull it apart because I don't know how to subtract. E to the x times e is e to the x plus 1. Those cancel, so it goes to e to the first. So is it top heavy, bottom heavy, or are they going to infinity at the same rate? Same rate.